Okay, next on the agenda, we need to talk just sort of briefly about even and odd functions, what that means, and just sort of a short visual test to be able to tell if one of your graphs is an even or an odd function, or could be neither. This is really about symmetry. And so we'll kind of define them that way. So symmetry meaning, right, is the function, is there sort of a mirror image aspect happening? And so let's just sort of dive right in. So we'll start with a function is even if it is symmetric to the y-axis. And so what that kind of means is a sort of left to right symmetry. So if I give us just sort of a quick little sketch over here, if this is just sort of an axis, so a classic symmetric function would be sort of one of our parabolas. In particular, if we sort of did a quick sketch of what something like just regular old x squared looks like, right? This would be, if I was better at sketching, this would be a pretty clearly symmetric function. You have the same kind of behavior, right, coming on the right and the left. Essentially, if you took this and you flipped it left and right, or if you like folded it in on itself like a sheet of paper, you would end up with both sides of this graph overlapping. They would just sort of connect right in a left-right kind of mirror image way. This is connected to sort of in polynomials, right? The name even sort of comes from in polynomials. It's connected to whether the exponents are even or odd. You guys will get into this a little bit more in the pre-calculus class. So we'll just do things visually for now. An odd function is going to be what we call symmetric to the origin. So the origin, right, is our sort of center point on the graph, 0, 0. So this is a little tougher to explain in so clear a way. It's not like a top-down symmetry, right? A sort of top-down symmetry. If you had that, you wouldn't have a function, right? Because you'd have an overlapping thing and you'd fail the vertical line test. So this isn't that. What I'll do is I'll sort of call this, we'll say sort of a type of diagonal symmetry. So that's a little sort of hand wavy as far as a definition goes, but this sort of visual test is a little hand wavy. So we'll go with that. What this would look like, let me give you sort of a quick sketch and then we'll do a couple sort of short examples, right, is essentially so a symmetry, so on the diagonal around the origin. So if I started with, you know, a parabola type curve over here, so what would be happening is essentially it's a left-right flip, but it's also a top-down flip. So it ends up being almost kind of a diagonal type flip. So you get a mirror image of this, but instead of going up on this side, it does the opposite behavior and it curves and goes downwards. This would kind of be a graph of something like x cubed. That would kind of be the classic example, and you'll probably note, right, if we compare these two, if this is x squared and this is x cubed, right, odd powers, odd function, right, x cubed, x raised to 3, which is an odd number, gives us this odd function that has this particular type of symmetry. I'm going to make just a couple sketches, and what we're going to do from there is we're just going to kind of identify whether each of these just quick informal sketches are even functions, odd functions, or they could be neither. So let me just sketch us a couple quick small graphs. I'm not necessarily bothering to put different, right, X or like Y values on here. We're really just doing this pretty informally. Let's say something kind of like this is our example A. I'll sort of draw 3 of these guys, and then we'll classify them one at a time. So that's B, and we'll do C down here. So ABC. So if we're trying to identify these as having any of these symmetric properties, kind of yes, no, even, odd, or if they don't, it could just as easily be neither. Certainly if we just sort of sketch just random kind of lines on the page, it probably won't be symmetric, right? So if we look at example A, one key thing to look for, right, is if it goes through the origin. That would be definitely necessary to have this origin symmetry. If we think of this as sort of flipping left to right, there's definitely some symmetry happening with the sort of shape of the curve here, but it's not the case that if I just like close this and sandwich them together, they're not going to line up. They're going to be out of line. But there is this sort of, right, if I flipped it and then flipped it again, right, there's this sort of positive value shifts here, and then it kind of mimics and does a negative shift here. So it's not even symmetry, but it is symmetric to the origin. This is going to be, for us, an example of an odd function. This is going to be symmetric to the origin. If we look at example B, as best as I can sketch it, this is one where if we took it and we sort of sandwiched it together, right, if we flipped it, or if we sort of put up a mirror here, would we sort of be getting the same image on both sides? And the answer to that is yes. It's not going through the origin, so it can't be odd, it can't be symmetric to the origin, right? Again, part of that is sort of flipping from a positive to a negative value and vice versa. In this case, we really have a left-right symmetry that's, in theory, right, pretty clear. Again, this is the limited only by my ability to sort of sketch these things. So this has the nice left-right symmetry going on, so this one is going to be even. My third example is a curve. You could kind of imagine maybe a version of this if it was kind of reoriented a little bit so that it went through the origin. Maybe it could be odd if you kind of lined up these curves just right and adjusted them a little bit. As it is now, though, it's kind of going through this random sort of negative value here. There's obviously sort of a positive curve here and, a matching-ish kind of thing here. But if it's not going through the origin, that kind of right away is going to mean that we're not symmetric in any particular way. So this is definitely not even. It doesn't have this left-right symmetry. It maybe could be odd if we shifted it around a little bit, but as it is now, it's not. So in this case, this is just neither. There's no symmetry here. So those are the characteristics we are looking for. So even, odd, or in the last case, no symmetry at all.